Welcome to Aquatics Live YouTube channel.
A quick update to the video here on the coil wrapping project. Essentially, I got a couple of these old cores. This one's pretty rusty. I picked the better of the two. My original one, it's in the motor and everything. But I wanted to experiment and see if I could rewind this and get it a little bit better current out of these for doing extra. Do a little show and tell on the little rig here that I built. I did a short on this on YouTube, just showing it running. But I'm just going to kind of show how I put this together. It's kind of a rig setup. It's not meant to be a professional one. I have seen how those work. They're really nice, but not everybody can afford that. Anyway, so this little wheel here is to clean stickers and stuff off. I got these for like cleaning caulk and things off a few years ago. So I got a pack of them. Anyway, there's a spare one. The only reason why I use this is it's got the some holes in here, and I can kind of choose where I want to mount the coil on here. I've used this a few times for different to do a few different coils. So so I got washers in between there on this side and on this side. It's just so the wheel doesn't rub on the wood. And remarkably, this has done a few coils, and it's still, you can barely tell. So I did put grease inside in between here where the shaft goes through. But that's pretty much it for that part. And then there's the spool. You could make this out of wood, but I just 3D printed these little L brackets, or you could just bend some little metal, and you just need to hold the spool. The trick to this is you need to put a little spring on there for spring tension, because you don't want this free spinning on here because you'll get slack. You got to get quite a bit of tension on it so it draws the wire into the center, into the core here, as tight as possible. So yeah, essentially it just goes in there, drop it in. This little piece goes in here. So we'll get the screw started over here. And then this goes in here, and we put the spring in, and then you just kind of thread it through, and that puts the tension on the spool. You can check out the short of this running. It's on my YouTube channel. But yeah, that's pretty much how that works. These slower, like this is a little 12-volt one. I have another 4-volt one. They go slow enough to keep that spinning real nice and slow for you. So, and that's because you're doing this kind of by hand. I mean, this assists you, but in order to get the wire wrapped on that core in the right way, and I made these some little wood blocks to set this on. But in order to get that on there, you need to be guiding the wire on the spool in the right spots. Usually, so if it's the manufacturer or whoever makes the wire here, they'll wind it on here, but sometimes it'll be on the end, on the edges for a really long time, and that'll build up too much wire on the outer edge of your spool, of your core. So you got to be watching it and just kind of run it. What I did for a while is I put a zip tie around here just to hold it at the slowest speed, and then let it run. But then there's times when I needed to guide the wire around, and you can speed it up too, once you get to a good pace to it, but go slow. All right, so that's pretty much that part of it. Actually, I just tied it on with a piece of wire through this loop here, and then tied it through these holes. So the core is centered. That's the big thing, is make sure it's centered. And since this is rubber, since this is rubber, it really holds the core from moving around. These are on Amazon, I think, still. So, I mean, I got it a few years ago, but now there's like the math behind this process here. Mind my cross here. I'm just grabbing a piece of cardboard. Okay, so I cut all the wire off of the core, and then got a core weight for it, or the tear weight, or whatever you want to call it, but it's the core. We'll write that down. So and that's essentially the tear weight for your scale. And this particular, the one that I was using is 143 grams, and the wire remove was 25 grams. There's tables on the internet. I'm just going to give you the actual information that I figured out, so you don't have to go look it up. This happens to be metric wire, and it was 1.25 millimeters in diameter. So just with the caliper, I measured it. So we'll just do this 110 per km. So it's 110 grams per kilometer. So if you do the math there, you got the 25 grams, and you divide that by the 110, that gives you 227 meters. So that's kind of what we're after. If you're winding bigger wrapped coils with larger wire, you should really count the wraps on the coil. But when you're doing the really fine wire, this is the way that I've always done it, is you weigh it and figure out the length. It's not perfect. And then there's other problems, is the wire that's being used on these, it can be different grades of copper, and they all will have different exact information. So there's a lot of variation here. You also have to deal with, when you're going from a small size to a big size, there's the resistance of the wire is reduced. That also means that the voltage drop is reduced on on the last chunk of lead. So if, say, you got a 1-inch chunk of lead that's wrapped around, or your little hookups on there and stuff, as you go larger, there's less voltage drop on that. So there's a lot of variation. So this is not a perfect world situation. And I'm assuming with these coils that they're, not all the same. They might be off, one might be off 50 feet from another one, or, meters. So you never know. But this gets you close. My math on this is that I got 225 meters on here. And I left it like this. I am going to put the leads on it yet. That's the ones that go on there. These the ends of the strands, they get soldered onto these, epoxied down to the coil, and then they get wrapped in tape, and then epoxy on all the sides and stuff. So there's a lot to this. I can kind of go through the rest of the math. So that comes out, I'll just do that. So this is 30 AWG. Oops. Anyway, 30 AWG. So this happens to be 453 grams per km. So we're talking like 4 times the amount, essentially. And that gets you right down to like, okay, so we have to make sure that the weight is 4 times the weight. So you have to get the equal amount of millimeters, though. So once I got done, I'm at 102 grams. So I am essentially 4 times the weight in grams on this. And that was pretty much my stopping point. Stop every once in a while and weigh it on the scale and get my number as close as I could to 4 times 25. So it wasn't too hard to figure that out. Yeah, so I got on here. This is Captain tape wrapped around here. This is high temperature tape. I did leave around the edges here. The tape is sticking out on the edge. and it's on purpose to create a little trough because this is overwound a lot. So when you overwind one, you need to make sure that you seal in the edges. So I'm leaving this open. I'm going to epoxy in this cavity over here and over here. And that's going to take a while. I'll have to do one, let it dry for a day, flip it over. So this, there's more to this. The other thing that I noticed with these is don't get them wet. I mean, yeah, you might be able to get them wet for a little bit, but with the way how these cores are set up, um, they aren't completely sealed. So the water will get in there, and that's going to be a pretty easy reason for why these go bad a lot, is that the copper will separate if it gets wet in there. Other ones that I've seen, they'll completely dip them, including all this copper core. The rust will separate the copper core, and it will cause problems as well. Okay, we got the update to this for this weekend. I got to work on this more during the week. I'm probably going to do a video on just do a short with the oscilloscope view of this on a motor. I'm not going to be able to run the motor. It's like a ton of snow outside and stuff. So, but I'm going to do what we did before, just run the oscilloscope, see if we're getting voltage out of this and what we're sitting at. But this is the update on it. I did not wrap it in, I mean, it's got the Kapton tape on there, and then this is the epoxy covering on there. I decided that's enough for this. Well, just because we really can't fit any more in there. So I put an extra layer of epoxy on it. I painted it on there twice. So we have a nice thick coating of it on there. On the end here, I did, this is just silicone over this area where these wires are, so I can peel the silicone off when I want to solder on the white wire with the diode. But for testing, I'm just leaving that off, and I want to make sure that this works as is, and I can test it without that third wire. I'll just jump off of the red one, which I may end up doing, just make a wire that comes off of here that has the diode on it in line. So still deciding on that. This is my little test rig. It's got my diode and the LED. When I tested this before, the LED would blink. So it wasn't enough to keep the capacitor charged up and maintain the light. It was just blinking. So my hope after this is done that I can get enough current out of here that I can maintain the capacitor and get a steady, at least a steadier light anyway. So here's the other things going on with this. It is overwound, I mean a lot. So on the old one, there's plenty of clearance here. I've 3D printed this little circle because the magnet is a pain in the butt to try to figure out if it's touching. Plus, it has these chunks missing here. So once you get it kind of straight in the hole, then you can't see the clearance on the side. So I just made a perfectly round one, an exact copy of the circumference of it. It's actually a tiny bit larger than the magnet, but only by like a 0.2 millimeters. I just made it a tiny bit bigger to make sure that I did have enough clearance in here. Also, I took the drill and I did widen these holes out sideways on here a little bit, so I have a little bit of wiggle room to move it away from the center. So we put it in here. If it is touching when we get it in the motor, I can pull it away, and you'll be able to, there's plenty of gap in there if I end up having to pull it away. In fact, I may try to do that right away, because the field will be better. That's pretty much the update on that. I kind of go over the process here. Is epoxied them, and then I have this little This is for reflow work, soldering. So um, so what I was doing is I get some epoxy on there, let this run, dry it out enough so then I could turn it. It sped up the process instead of having to wait each day and going around. I got all the stuff done yesterday, and then I just finished up the silicone this morning. And so during the week, I'm going to get a oscilloscope video up showing the outcome of this, and we'll see what we get. So the resistance on here is approximately 90 ohms, which is about perfect for the amount of windings compares the amount of wraps around the coil for this gauge of wire to equal the same as the previous one. So I'm really happy with that. I'm hoping this is the right one. If we need to get the voltage higher, I will have to go down in wire gauge to, this is 30. I can go to 31 and get more wraps on it to raise the voltage. But I'm really hoping that this works out anyway. So